Welcome to the session on integration, integrating standard functions. The objectives for this session are to integrate standard mathematical functions such as trigonometric and exponential functions. The standard formulae for integration will appear one by one on your screen. The link, remember, between differentiation and integration is that integration is the reverse of differentiation. We will use our knowledge of derivatives to integrate functions which we are familiar with, in particular those on the left-hand side of your screen. Let's take a look at the first formula. If y equals x to the power n, then remember that dy dx equals n times x to the power n minus 1. Notice that we've multiplied by the index in order to differentiate, and then subtracted 1 from the index, as shown. To reverse this process, in other words, to integrate, we need to add 1 to the index and then divide by the new index. In other words, if we integrate x to the power n with respect to x, then we add 1 as shown, so we have x to the power n plus 1, and then divide by the new index, in other words, divide by n plus 1. And of course, at the end, we add a constant of integration. And in this example, n is not equal to minus 1. Now let's take a look at the next formula. Remember that if y equals e to the power x, then dy dx equals e to the power x also. So for this case, integrating is very straightforward. It doesn't really change. So we have that the integral of e to the power x dx is equal to e to the power x plus c. For formula 3, we have that if y equals ln of x, then dy dx equals 1 over x. So reversing this process gives us that the integral of 1 over x dx equals ln of mod x, and here the modulus sign removes the difficulties which may arise when evaluating an integral for x values which are negative. And of course, added to that is the constant of integration. Now for formula 4. In order to derive this formula, remember that if y equals sine x, then dy dx equals cos x. And so the integral of cos x dx equals sine x plus c. For formula 5, if we want to derive this, remember that if y equals cos x, then dy dx equals minus sine x. So integrating gives us integral of sine x dx equals minus cos x plus c. And now for the next formula. For this, we're going to use the fact that if y equals tan x, then dy dx equals sec squared x. So again, if we integrate sec squared x dx, we obtain tan x plus c. And for the next formula, remember that if y equals cosec x, then dy dx equals minus cosec x cot x. So integrating cosec x cot x dx gives us minus cosec x plus c. And similarly for the next formula. If y equals sec x, then dy dx equals sec x tan x. And so if we integrate sec x tan x dx, we obtain sec x plus c. And finally for the last formula. We know that if y equals cot x, then dy dx equals minus cosec squared x. So if we integrate cosec squared x dx, we obtain minus cot x plus c. Now let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at part A first. We are required to find the integral of 3 sin x minus 2 over x plus root x dx. So let's solve this. If we integrate this expression, we're going to leave the first bit as it is and change root x to x to the power half, because that will make it easier for us to integrate. So integrating 3 sin x dx gives us minus 3 cos x, and integrating minus 2 over x gives us minus 2 ln mod x, and integrating x to the power half, remember we add 1 to the index and then divide by the new index in order to integrate. And of course the plus c at the end. And finally, tidying up, we leave these expressions highlighted in red as they are, and this expression becomes 2 over 3x to the power 3 over 2. And now for part B. We are required to integrate the expression shown on your screen. So let's solve this. Tidying up gives us that 1 over cos squared x is sec squared x as shown. Sin x over cos squared x is sin x over cos squared x as shown. In this term, cos squared x is left as it is, and sec x is written as 1 over cos x, and finally e to the power x is left as it is. So tidying up some more gives us sec squared x plus tan x, since we're dealing with sine over cos, times sec x, since there's a 1 over cos in this expression as well. And of course here, cos squared x over cos x is simply cos x, and e to the power x is left as it is. Finally, let's integrate. Integrating sec squared x dx gives us tan x. Integrating tan x sec x gives us sec x. Integrating cos x gives us sin x. And integrating e to the power x gives us e to the power x. And of course we have the constant of integration at the end as shown. Now let's take a look at the next example. Pause the video and have a go. Press play when you're ready to view the solution. In this example, we're required to find the exact value of a, given that a is a positive constant and the expression shown on your screen holds. So let's solve this. Let's explore the left-hand side of this expression first. Here, so we have the integral from a to 2a of 3x minus 1 all over x dx. Let's simplify the bit inside the integral sign first. So 3x minus 1 all over x is 3 minus 1 over x. Integrating 3 with respect to x gives us 3x. And integrating 1 over x with respect to x gives us ln of mod x. Since we're examining a definite integral, we don't need to add a constant of integration. Next, we plug in the limits, as shown, into this expression. So we have 3 times 2a minus ln of mod 2a minus 3a minus ln of mod a, to give us 3a plus ln mod a minus ln mod 2a. So we have that this is equal to 3a plus ln mod a over 2a, and of course ln of mod a over 2a is equal to ln mod a half, as shown here, plus the 3a at the start, which is left as it is. So we have that our integral is equal to 3a plus ln mod a half. However, we know from our original question that the integral is also equal to 6 plus ln of a half. Now, of course, ln mod a half and ln a half are the same. So therefore we need to equate 3a and 6 to give us that a equals 2. This brings us to the end of this session. If you have understood its contents, you should be able to integrate standard mathematical functions such as trigonometric and exponential functions. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.